Dear participants of the SWST 2020, my name is Vicky Reiche from the Technical University of Braunschweig, and I want to present our results on our study of a one-shot process for wood-based composites. So let me come to the motivation. So as everyone knows, the environmental pollution, the increase of CO2 emissions results in social rethinking of using products and parts used in several industries and as well in the private sectors. But especially the transportation sector is targeted by law limitations to reduce weight and therefore CO2 in its applications. In order to realize this weight reduction, hybrid material components made from different materials offer a good weight saving potential and equal or better mechanical performance and functionalization. Our department focuses on hybrid materials made from fiber reinforced plastics, which are also called FRP, and metals. And we want to use this knowledge to process hybrid materials made from plastic and wood. The process we're targeting is shown on this slide. Usually you produce a part in several single steps, and necessarily a lot of handling operations are needed between them. What we want to develop is a combined process where all process steps are integrated in one tool. In our case, this means that the trimming and forming of wood sheet is integrated in an injection molding mold. And this is a process, the injection molding, to apply the polymer component. So the advantage resulting of this is a shorter process time and therefore higher economical attractiveness regarding cost and quality, which is especially important for the enable the bio component usage. Our study was split into two parts. The first one was to show the process parameters for the bonding agent we wanted to use, which is maleic anhydride soft in polypropylene. And we detected the influence of the melt temperatures and the weight ratio or weight content in the polymer. The second one was to evaluate the influence of a shear cut surface of the wood component on the bonding strength of the overall hybrid component, which was done by using tensile specimen. In the following, I want to show the results of these two investigations. So the first one, as you can see, are the results of the influence of the bonding agent, which were defined by using 3-point bending specimen. The results showed the increasing temperature of the polymer melt lead to a decrease in the bending strength, which is the result of the chemical reaction between free OH groups and the maleic anhydride, because higher temperatures lead to less free OH groups and therefore less bonding. Our optimal parameters we investigated at 190 degrees Celsius and 5% weight ratio, which we used in the next experimental step, which was the investigations on the bonding strength of the combined hybrid prototype. First, we investigated the shear cutting force of the on two different wood types, which were beech and oak. The cutting force did not differ, so the specific wood structure seems not to have an influence on the cutting force. When using different cutting mechanisms, an angled cutting tool instead of a straight cutting tool, it showed that the angled cutting tool reduces the cutting forces around 20%, which is pretty important for a one-shot process, because the one-shot process directly is influenced by the overall closing force, which is influenced by a low or a high cutting force needed for the wood material. The investigations on the bonding strength are made on tensile specimen, as shown in the upper right picture. The results of the bonding strength are shown in the lower left figure. As you can see, the values determined differ between the wood type, but also between the cutting tool angles. Overall, it can be said that the values are not that high compared to other bonding strength of hybrid materials. Typical value starts at 15 Newton per square millimeter. So also we can see that the values did not show a high reliability. So we had high deviations between single parameters and there could not any significant trends be shown. what we assume to do is optimizing the testing specimen. So the relations we want to change in future experiments are the creating a higher surface area where the bond can be tested on. Thank you for your attention and enjoy the rest of the conference.